Here we have the definite integral going from 1 to 2 of 1 over x dx. We want to compute the left of 2, right of 2, mid of 2, and top of 2. And then we compare to the exact. Here I took the function 1 over x and draw it in here, and then I'm draw it in here. Then I want to find left of 2 and then right of 2. So first let's find left of 2. So the first step in here is to notate our interval, what's going from 1 to 2 from the limit of integration. And then we want to find delta x, which is the width of each rectangle. So delta x is going to be equal to b minus a over n. Now n gonna be equal to 2. That means we're gonna present the area and the curve by two rectangles. And then b and a is the endpoint of the interval, and these are found from the limit of integration in here. So again, a gonna be equal to 1, b going to be equal to 2, and then n going to be equal to 2. Therefore, delta x is gonna be equal to 2 minus 1 over 2. That's gonna be half. Now, let's draw the estimation in here before we compute it. So the first step is to point where is the midpoint. Note that the midpoint gonna be the midpoint between our interval 1 and 2, so that's gonna be 1.5. And then we're gonna draw left of 2. We're gonna draw that going from the left. So I'm gonna start from 1 until I hit the curve, and then I'm gonna move to the next point in here, which is 1.5. And then to draw the second rectangle, I'm gonna go from 1.5 until I hit the curve, and then I'm gonna go to the next point, which is 2. Notice in here, this point here is f of 1, and then this point in here is f of 1.5. So remember that our function is gonna be 1 over x, so that's gonna be 1 over 1, which equal to 1, and that's gonna be 1 over, and then 1.5 is 3 over 2, so that's gonna be 2 over 3. Also notice this is delta x, which is the width of each of the rectangles in here. Now to present left of 2, I'm gonna present it by these two rectangles, so it's gonna be this rectangle in here, and then gonna be this rectangle. So it's basically the area of this rectangle plus the area of this rectangle. So we already know the width, which is a constant in here, it's gonna be half. And then I already found the height of each rectangle. The height of the first rectangle is 1, and then the height of the second rectangle gonna be 2 over 3. So left of 2 going to be equal to f of 1 multiplied by delta x, and then plus f of 1.5 multiplied by delta x. That's gonna be equal to 1 multiplied by delta x, which is half, and then plus, and then f of 1.5 is 2 over 3 multiplied by half. This is gonna be estimated to 0.8333. So that is left of 2. Now let's move to right of 2. Note in here that the sub-interval is the same, which is 2. Therefore, delta x is going to be the same, which equal to half. Note the first step is to notate our interval, which is going from 1 to 2. And then here we have two sub-intervals, which means two rectangles. And then I'm going to start drawing these rectangles from the right. So I'm going to start drawing these from 2 until I hit here. And then I'm going to move to the midpoint, which is in here. That's going to be 1.5. And then I'm going to start drawing the next rectangle from 1.5 until I hit the curve. And then I'm going to move to number 1. Note this point in here, that's going to be equal to f of 2. And then this point in here going to be equal to f of 1.5. So again, f of 1.5 going to be equal to 1, and then over x, which is 1.5, which can be written as 3 over 2, which can be written as 2 over 3. And then we have f of 2, so we're going to have 1 over 2. Now remember again, right of 2 going to be the estimation of the area under the curve in here. And that estimation has two rectangles. So first, it's going to be the area of this rectangle plus the area of this rectangle. We already found delta x, which is this one in here. Now, we already found the height of the first rectangle, which is f of 1.5, and also we found the height of the second rectangle, which is f of 2. Now we are ready to compute right of 2. So right of 2 going to be equal to of 2 multiplied by delta x and then plus of 1.5 multiplied by delta x. That's going to be equal to half multiplied by half and then plus f of 1.5 is 2 over 3 multiplied by half. That's going to be equal to 7 over 12, which is going to be equal to 0.5833, and that is right of 2. Again, this is the graph of the function f of x, which is 1 over x. And then here I'm going to present mid of 2, and then here I'm going to present trap of 2. First, let's go with mid of 2. Remember, delta x is the same in here since the sub-interval is the same, so it's going to be equal to half. And then let's draw mid of 2. So the first step is to notate our interval was going to be from 1 to 2. And then the midpoint here going to be 1.5. So to draw the midpoint, we're going to go to the first rectangle in here, and then we're going to mark the midpoint in the first rectangle, and then until we hit the axis in here, and then I'm going to draw a straight line, and then I'm going to connect that straight line. And then I'm going to do the same thing for the second rectangle. So I'm going to mark the midpoint until I hit the curve in here. Then I'm going to draw a straight line, and then I'm going to connect the midpoint in here. So that is mid of 2. So notice here, this point here is going to be 5 over 4. And then this point here is going to be 7 over 4. Now, this point going to be corresponded to of 7 over 4. And then this point here going to correspond to of 5 over 4. Now, of 5 over 4 going to be equal to 1 over 5 over 4, which is 4 over 5. Therefore, of 7 over 4 going to be equal to 4 over 7. So mid of 2 going to be equal to of 7 over 4 multiplied by delta x and then plus f of 5 over 4 multiplied by delta x. That's going to be equal to f of 7 over 4 going to be 4 over 7, and then delta x is half, and then plus f of 5 over 4 going to be 4 over 5, and then multiplied by delta x, which is half. This is going to be equal to 24 over 35, which is going to be estimated as 0.6857. So that is mid of 2. Now let's move to trap of 2. Note in here that delta x is the same since the sub-interval is the same. So to draw trap of 2, first we need to notate our interval is going to be from 1 to 2, and then the midpoint going to be 1.5. So first, we're going to draw this straight line from each point in here. Then I'm going to mark these, and then I'm going to connect these by a line. So that's how we draw this estimation. Now we're going to use something called the trapezoid rule to estimate trap of 2. So using trapezoid rule, trap of 2 going to be equal to left of 2, then plus right of 2 over 2. Now we already found left of 2 and right of 2. So left of 2 going to be 5 over 6, and then plus right of 2, which is 7 over 12, and then over 2. That's going to be equal to 17 over 24, which equal to 1.7083. So that's trap of 2. So on the left side in here, I have our estimations. And then here on the right side, what I'm going to do, I'm going to compare it to the actual value of the integration. So remember, we have the integral from 1 to 2 of 1 over x dx. So first, what's the antiderivative of 1 over x? It's going to be natural log of the absolute value of x. And then we're going to evaluate that at 2 and 1. So that's going to be natural log of the absolute value of 2 minus natural log of the absolute value of 1. Since these are positive number, that can be written as natural log of 2 minus natural log of 1. Notice that natural log of 1 going to be 0. Therefore, we'll end with natural log of 2, which equal to 0.06931. Now, let's compare our estimations on the left to the actual value of the area on the right. Note in here that the closest one here is gonna be mid of 2 and trap of 2. However, the closest one is gonna be mid of 2. This is the closest to the actual value of the area.